Okay. Find the slope of the tangent to the curve, this. So this is a wonderful curve. We would like the slope of the tangent to that curve at this particular point. So the slope of the tangent equals the derivative function. Now, I'm not going to do the limit anymore because I don't do limits anymore. What I want to do is I want to find the derivative of y. So the derivative of y is going to be the derivative of the first term. Now, again, I don't have to write this except that I'm trying to talk to you guys and I want you to see what's happening. I normally wouldn't do this if I was just doing my homework, but that means the derivative of the first term subtract the derivative of the second term, which allows me to do 6x squared minus 12x. So that is a function. This is the derivative function. And it gives the slope of the tangent to the original function for any value of x. Any value of x. Any. Am I making that clear? Any value of x. Any. I don't think I can say that anymore. We want it at a particular point of x. So I've used that notation with you, which means the slope of the tangent such that x equals 1. Is it a big jump to do that notation? That means the derivative function when x equals 1, which will be 6, 1 squared minus 12 times 1, which will be 6 minus 12, which will be negative, is that right? I think so, negative 6. I think I got that wrong when I did it with someone else. Natalie, I think you and I went over this. I think you might want to check that. I might have goofed when we did it in the library. Okay, so that looks like it's giving me what I want, and therefore the slope of the tangent to f of x when x equals 1 is negative 6. Okay? Okay. Write an equation of a tangent to the curve. Now there's different. This was the slope. This is the equation of the tangent. Big difference. To come up with the equation of a tangent or the equation of any line, I need 2 points or 1 point and slope. That's what I need. So let's come up with the slope. The slope is going to be f prime, and it's actually the slope of the tangent to this puppy. So that's going to be negative 3x squared plus 6x. That's it. That's 0. If you don't know where that came from, go back over everything else I've done. Now you want the slope of the tangent at a particular value when x equals negative 2. So that's going to be negative 2. Well, I'll write it out so everyone knows where it comes from. Oh, no, Natalie, I think I got it right. This is where that negative 24 came in. Okay, so that's my slope of my tangent. I need a point of tangency. I need a point on the tangent. Is the point of tangency. The point of tangency, if you remember, so take a curve, take a point of tangency. That point not only is on the tangent, but it's also on the curve. So this x value here and this range value, this point, x comma f of x, lies on both the function and the tangent line. So what I'm going to do is I'm going to take the point of tangency is, they told me x equals negative 2, f of negative 2. Now not f prime of negative 2, but f of negative 2. So plugging in negative 2 here, I guess I'll get negative 8. Just write that down somewhere. I guess I'll get negative 8. I guess I'll get 4. I guess I'll get negative 12. No. Negative 8. Negative 2 will give me 4 plus 12. And then negative 2. So that's going to give me 8 minus 2 is negative 10, so it's 2. That's my point of tangency. This point here is, well, negative 2, 2. So then I use y minus y1, and I've explained where this comes from a couple of times. I don't really want to do it again. And my point that I'm going to use is this is my x1, y1, and my slope is right there. So the slope's going to go in here. My x goes in here. My y goes in here. So I've got y minus 2 equals negative 24x minus negative 2. Y minus 2 equals negative 24. X plus 2. Y minus 2 equals negative 24. X minus 48. Because I want it in standard form, and we've talked about what standard form is, ax plus by plus c equals 0, where a is greater than or equal to 0, I'm going to bring this puppy over here. So it's going to be positive 24x plus y. Bring that over, it's going to be positive. So it's negative 46. Positive 46 equals 0. This, ladies and gentlemen, is the equation to the tangent line of this curve when x equals negative 2. That's it. That's all I got. This homework is from your yellow textbook. The homework that I want you to do is in the post. It's all from your green textbook. This is extra if you so wish it. See y'all later. Bye-bye.